Good evening, fellow scholars. We're going to be teaching y'all about the algebraic reasoning, graphing, and connections with geometry. I'm Faith Bratton.
I'm Alyssa Pierce.
I'm Chelsea Schlottman.
And I'm Heather McPherson.
Okay.
How could you represent a function using a graph, Alyssa?
Well, that's pretty simple. So representing a function by using a graph is very easy. I like to use Excel for my graphing. So let's take question number 2, for example, that we used on the homework. On this chart, we have two functions, f of x equals 3x and g of f of x equals f of x plus 8. Our values for x are 0, 1, 2, and 3. So once we've filled out this chart on Excel, the cool thing is you can go to, this is step number 2, you go to insert, and then you can insert a chart, a line chart on there. And once you've done that, you see that it is finally graphed. So our graph is completed once you get that done.
Okay, next one.
So what are variables, Faith, and how did you use them in identifying functions on your graphs, charts, and diagrams?
Variables can be written or used as any symbol, such as letters, as being used here. They're using X and Y. They are used to show an unknown expression. I use variables in my graphs to help explain the difference between Y and X, the exponents on the graph, and the different graphs represented in question 1. In this question, variables were used to represent the correlation of functions. So in this one, variables were used all through the lesson, especially in the function table on the input and output charts. Oh my gosh. Okay, as being shown here, we're using the X and Y in this question because to represent the functions. Variables were used all throughout this lesson, especially in the input-output chart right here. Okay, in the input and output chart, you're being asked to plug in a variable to the chart containing variables such as the f of x equals 3x. Using the variables x, variables don't have to be represented as just x and y. They can be used as pretty much any letter in the alphabet. Or any symbol. An input and output chart is when you're given an equation with variables. You put the variable in the chart in the input, and you come out with another variable to finish the equation on the output.
Hey, Chelsea, can you describe what each axis represents on the provided graph?
Yes, on this provided graph, it actually shows you it's labeled here. The distance traveled is on the x-axis, which is the horizontal line here going from left to right. And then on the vertical line, the y-axis, it's going to be the height. So for an example, a ball that has been dropped from a specific height, which I have here labeled for this red dot, as it bounces, it gets higher and then it gets lower. And as it travels further and further, you can see that the height kind of dissipates and it just stops bouncing. So for the x-axis, you see that the distance traveled, it goes on and on and on until it stops here and the ball stops bouncing.
Okay. Heather, what is a function?
A function is a special relationship where each input has a single output. Most often we see it written like this example, f of x equals 3x or g of f of x equals x plus 8. You can show your work with functions by graphs and by tables.
Okay.
Melissa, how can you determine which quadrant a point falls in?
Well, to determine that, first we must label the 4 quadrants on a coordinate plane. So starting in that upper right corner, you see kind of a square thanks to the x and y axis. So from there you go counterclockwise to the quadrants 2, 3, and 4. So quadrant 1 is where both x and y of an ordered pair is going to be positive. In quadrant 2, x is negative and y is positive. And in quadrant 3, X and Y are both negative. And lastly, in quadrant 4, X is positive and Y is negative. So as you can see, I've used one of the problems from the homework. The point where the purple happy face is 6, -1. So that happens to fall into quadrant 4. So, hey, Faith, what does X and Y mean?
X and Y mean they are the coordinates on the axis or the axes. In our graphs, the x-axis is the horizontal line and the y-axis is the vertical line. The x-coordinate gives the distance of the point to the right or to the left of the vertical line. It can be positive or negative in the direction of the x-axis. The y-coordinate gives the distance of the point above or below, positive or negative, of the horizontal axis. The x and y are used in our first graph to define the slope, and you're using and finding the x and y allows us to know where to plot our lines on the graph to identify the line given, as you can see, as in the x and y, x and the y.
Hey, Chelsea, how are variables used in function problems?
Well, as you can see here, a variable is a letter in an equation that can be changed to get a different outcome. For example, in the above problem here, we see f of x equals 3x in the second column. If we plug the values in that we have listed for the variable of x, we can plug that into that function and it will give us an outcome. And then on the third column here, you see the g of f of x equals the x that we previously had gotten plus 8. So we plug that in and add the 8 as well. So the variable gives you the answer of 0 for the first one and 8. And as you can see on the graph, at 0, it goes up to 8. And then it goes on, if you look at each different answer here on this little table chart, it does the same. It goes to 1 here on the blue line and the 11. So variables can be used to plug it in and find an answer.
Hey, Heather, can you tell me what is the equation for finding the slope?
Yes, to find the slope of two given points, we have an interesting equation. The equation is m equals y2 minus y1 divided by x2 over x1. We're given 2 points, 3, 1, and 5, 5. Now once we put those, we can put them into the equation. We know our 5s, our y's are 1 and 5, and our x's are 3 and 5. The equation will be 5 minus 1 divided by 5 minus 3. And once we subtract the top and bottom of the equation, we get 4 over 2, which can still be simplified. So the slope of the line is going to be 2.
Oh, this is me. Okay, Alyssa, do you prefer to find the slope by using algebra or using the rise over run method?
Well, as Heather just explained, she used the algebra, so I personally like to use the rise over run. I'm a visual learner, so when I graph this type of problem on Excel, I can solve it quicker. So, for example, on question 3 of the homework, the line was able to perfectly fit a right triangle, making it simple to find the slope. So you can visibly see the rise is 4 and the run is 2. So whenever you're dividing, you put rise over run. So 4 divided by 2 makes the slope 2.
Hey, Faith, what is a slope?
A slope is the properties of a line that distinguish different lines from one another, identifying their coordinates, directions, or steepness. We find these by the notation of slope. The slope can be defined from lines, line segments, and a line, or the length of a line segment. There are many ways to find the slope. In question 3, we found the slope by using the rise over run method, where we have the rise, which was 4, going up the y-axis, and the 2, which is the run, which is on the x-axis. You can find the slope using this method by placing the y-coordinate over the x-coordinate dividing them by each other to find the slope. Another example of the slope is like the one we use in question 3, where we have the 2-point form of the equation of a line to find the slope. You plug in both x and y coordinates onto the equation. M equals y2 minus y1 over x2 minus x1.
So Chelsea, how would you know what type of shift a slope has?
Well, one way to find out the type of shift is to use the formula for the slope, which I have provided right over here for you. First, you'll start by labeling the coordinates given, x1, y1, x2, y2, and then you're going to plug those numbers into the formula provided to get the slope. And an easy way that I like to do it is the visual, like Alyssa had explained as well. And it's a lot easier to see the shift because you can actually count how many it goes up and how many it goes over. Once it's graphed, you can see where the line will actually go up. You can visually count them, like I had previously said. So as you can see on this one, though, we have the 5. The x is 5 for both of our numbers here. Our x, sorry, it is the same. So we have the 5 labeled here with this orange dot, and then we can see that our y's, we have one positive 8 and one negative 8. So we don't have an exact line here. It's kind of just scattered all over the place. So that tells us that it is undefined. But for a problem like this, you don't actually have to graph it first to see that it's undefined. If you just do the math, once you plug all that in and you see that the denominator is a 0, that automatically tells you that it is an undefined slope. Hey Heather, when given coordinates, am I doing the wrong one? Sorry. Okay, I guess it is. Hey Heather, when given coordinates, which number represents the x-axis and which represents the y-axis?
So here we're given 2 points, 5, 8, and 5, negative 8. So how do you know which number represents the x and which the y? Well, we know that the x value is always written first. So by looking at the coordinates, we know that both x values are 5, which leaves the 8 and negative 8 to be your y values. Now that we know which values are the x and y, that tells us which axis to look at to plot the points. First, we can look at the x-axis. You'll move over 5 to the right because it's a positive number, and then you can go up 8 on the y-axis to plot the 5, 8, and then go down 8 to plot the 5, negative 8.
This one mine? I think it is. Okay. Does an x and y axis always have to be represented on a coordinate plane, or can it be represented in other forms?
Well, the x and y axis aren't just used on coordinate planes. An x-axis, by definition, is the horizontal number line, and the y-axis, by definition, is the vertical number line. So looking back at question 1 in the lesson we did, we can see that these aren't your typical x and y axes. There are no numbers on the problems, just words and lines. So as you can see on the left, I've provided a typical x and y axis that we would see when plotting points. And on the right, I've given you an x-axis that shows distance traveled in miles and a y-axis that shows gas in the tank.
Hey Faith, what is the difference between a linear function and a nonlinear function?
A linear function is a graph that is plotted in a straight line. As we can see in question 1, it's a straight line, so it is linear. A nonlinear function is the opposite. It's a function that is nonlinear. We use these two different types of functions in our question graphs, as you can see represented in the PowerPoint. The linear function is used in question 3, for example, where we were given both x and y to plot the graph into a straight line. A nonlinear function or equation is being shown in question 1 when we are being asked to show the difference when you're asked to fill up the gas tank along with your distance traveled, the length of time that the elevator stopped, the time of a bouncing ball, and the length of a flagpole shadow. As you can see in question 1, there are no obvious straight lines, such as the graph of the flagpole where it loops, the time of the bouncing ball dropping where it was non-linear because it kept going back and forth, going up and down, and there were no straight lines.
Chelsea, how can you graph a given set of coordinates?
Say we are given coordinates -2, 0. The -2 is the x value and tells us that we will need to move 2 places to the left or to the right. To know which way we are going to go, we need to see if the number is a negative or positive. So for this one, the -2 is negative, so that tells us that we need to move to the left along the x-axis. Next, we would look at the y value given, which is 0 here. That value will tell us whether we need to move up or down along the y-axis. Since it is a 0, that says we do not move up or down, we just stay on the same spot. So our dot would be placed on the -2 along the x-axis, and we would move up or down since the y is a 0 value. And then we would do the same for the remaining coordinates that are given to find our line.
Heather, what are tangent lines?
A tangent line is a line that touches a curve at one point without crossing over. So in this example, I have a circle that has a radius of 9. So my points are 0, 9, 9, 0, 0, -9, and -9, 0. We know that it does not cross. We know that the middle line that has the coordinates -9, 0, and 9, 0 are not a tangent line. But the lines at the top and the bottom are both tangent lines. Alyssa, what role does a variable play in a function?
Great question, Heather. So without variables, functions would not be solvable. So going back and looking at question 2 from the homework, we can see the variable x straight away. So a variable is a letter that represents a changeable quantity. So for this problem, x is going to represent 0, 1, 2, and 3. So for the given function f of x equals 3x, we multiply 3 by each given x value. So as we see, x is what makes this whole problem solvable.
Hey, Faith, what is a tangent line of a circle?
A tangent line of a circle, but before you can identify a tangent line, you must first know the definitions of a circle, which are circle, diameter, and radius, which all make up the circumference of the circle. The circle is a set of all the points on the plane that are fixed distance from a given point. The given point is the center of a circle, and all fixed distance is the radius, which is the center of the circle to the outside edge. We use this equation given in question 6 to find the tangent line, but we must know the slope along with at least one coordinate to plug into the equation. Hey Chelsea, what type of line would we get with the given equation?
To find the line for the equation shown, first we need to find out what m is. The m is equal to the slope. And to do that, we need to take care of the -3/4. We're going to take the reciprocal of that, which just means we're going to flip it over and get rid of that negative. So now we're going to have 4/3. Then we're going to use the formula shown, the y minus y1 equals m times x minus x1. Then we're going to use those values provided above as r, and we're going to label those x and y, or x1, y1, and we're going to plug those into the formula given. So then we're going to have y minus a -1 equals 4/3x minus 6. And we're going to take this 4/3 and we're going to distribute it across, and we're going to multiply it by x as well as -6. Once we do that, we're going to get y plus 1 equals 4/3x minus 8. And then we still need to get y by itself, so next we're going to subtract 1 from both sides, which would give us our final answer of y equals 4/3x minus 9. And on the next slide, I have graphed it for you so that way you can see what it looks like on an actual graph. And here you see the graph shown, and I have the equation put up here again. So you can see visually what we're going to do. We're going to start at the -9 that is provided. And you can see I have a dot over here on -9, 0. And the 4/3 is going to tell us how many we need to move up and over. Since it's positive, we're going to move up 4, and then we're going to move towards the right 3. And we're going to do that until we get a line.
Hey Heather, when working with parabolas, what are some similarities and some differences?
First of all, let me begin by pointing out the 3 parabolas we have in this example. We're using y equals x squared, y equals x squared plus 7, and y equals x squared minus 7. Just by looking at these 3, you can see they're all squaring 2, and the only differences are one does not add nor subtract any additional numbers. One adds a 7 and one subtracts a 7. By looking at the table, you can determine the outcome of all 3 parabolas, and then we can graph it. By looking at the graph, you can see the similar shape of all 3, and again the difference of where they begin. We have starting points at 0, 0, 0, 7, and 0, negative 7. Hey, Alyssa, what is the difference between an equation and an algebraic expression?
Okay, so to start, the definition of equation gives us a deeper understanding of the differences. So an equation is an expression that states that 2 expressions are equal to each other. So an expression simply states something such as a plus b. An expression can involve numbers, variables, or operation symbols. So in question number 5, we see that y equals -9/2 x plus 5 over 2. So that is actually an equation because you can think of equation means equal sign, y equals that equation. And then on the right, I have a plus b, which is just an expression. There's no equal sign. There's nothing to be equal to.
Okay, can you define perpendicular?
Okay, a perpendicular line is a line that meets or crosses another line at a right angle. Perpendicular means right angle. In question 5, we were asked to explain if the line was perpendicular, but no, it was not. The line was neither vertical nor horizontal, but in question 3, the line is perpendicular. As we see, the line is vertical. As you can see, it crosses the x-axis, and on this one, it's going at an angle, so it was not vertical nor horizontal. Hey, Chelsea, what is the radius of a circle and what is the diameter of a circle?
Well, first, the radius of a circle is a point in the middle of the circle towards the outer edge. So as you can see here in this example, the center is at 0, and then to get to the outer edge there, it is going to go all the way to a +9. So our radius for a circle would be 9 in this example. And the diameter is the distance across the circle from any outer edge to the other across from it. So in this example, you can see we start at -9 here along the x-axis, and then we can move all the way over here to the +9. So the diameter goes from one side to the other at any point on the circle. Hey Heather, how do we find a tangent line?
Okay, so remember earlier when I spoke about it, you got a tangent line does not cross, it barely just touches the curve. So I'm a visual person, so I draw out my square and my circle, and I go ahead and label my points since I know my circle has a radius of 9. Since I know that the points are going to be 0, 9, 9, 0, 0, -9, and -9, 0, once we draw the lines, we can visually see that they do not cross, and they are in fact tangent lines. So your tangent line will be at the top at 0, 9, and then another one at the bottom with 0, -9.
Okay, that is all we have for you on our slideshow, so thank you for watching. Stop.